Have you ever wished you had an entire team of AI developers, testers, and product managers at your fingertips, ready to collaborate on any coding challenge? Today, we're going to make that a reality. We're diving deep into the world of multi-agent systems, using Python and Microsoft's powerful AutoGen framework to build an autonomous coding squad. Imagine an AI team that can understand a feature request, write the code, test it, debug it, and even refine it, all with minimal human intervention. This isn't just about code generation. It's about building a sophisticated collaborative intelligence that mirrors a real-world software development team. The architecture we'll design allows each agent to play a distinct role, communicate, and work together towards a common goal, providing a glimpse into the future of software engineering. Get ready to orchestrate a symphony of AI minds. Before we jump into the code, let's lay down the foundational architecture. Our multi-agent coding squad will consist of several key roles. First, a product manager agent, responsible for interpreting the initial request and breaking it down into actionable tasks. Next, a software engineer agent, who will translate these tasks into executable Python code. Then, a quality assurance agent, tasked with rigorously testing the generated code, identifying bugs, and providing detailed feedback. Finally, a user proxy agent will act as our human interface, allowing us to observe the conversation, provide feedback, and ultimately approve the solution. This modular design ensures clear responsibilities and efficient communication, preventing agents from stepping on each other's toes and ensuring a structured approach to problem solving. Each agent will be powered by a large language model, giving them the ability to reason, generate code, and understand natural language instructions. Setting up our environment is the first practical step. We'll need Python installed, of course, and then we'll install AutoGen. The command is straightforward: pip install AutoGen. After that, we'll configure our API keys. For this tutorial, we'll be using OpenAI's models, so ensure you have an API key ready. It's crucial to manage your API keys securely, either through environment variables or a configuration file that's not committed to source control. AutoGen provides excellent abstraction for connecting to various LLM providers, making it easy to swap models if needed. Our setup will involve creating a config list that specifies the model names and API keys, which AutoGen agents will then use to communicate with the underlying large language models. This initial setup is the gateway to unleashing our AI team's potential. Now, let's define our agents. With AutoGen, agents are instantiated as either assistant agent or user proxy agent. Our product manager and software engineer will be assistant agents, because they primarily generate content and respond to prompts. The quality assurance agent will also be an assistant agent, but with a specific focus on execution and verification. The user proxy is, fittingly, a user proxy agent. This distinction is key. Assistant agent typically relies on an LLM for its reasoning, while user proxy agent can optionally execute code and usually serves as the bridge to a human or external tools. We'll give our agents clear system messages, defining their roles and expected behaviors. For instance, the software engineer agent system message will instruct it to write Python code and explain its logic, while the QA agents will tell it to rigorously test the code and report findings. Each agent will have access to a specific large language model configuration. The power of AutoGen truly shines in how we orchestrate agent communication. We'll link our agents together to form a coherent workflow. The initiate a cat method is where the magic happens. We'll start by having the user proxy agent initiate a conversation with the product manager agent, providing the initial coding task. The product manager will then interact with the software engineer to get the code written. Once the code is available, the software engineer might prompt the QA agent to test it. The QA agent can then report back to the software engineer or even the product manager. This conversation flow isn't hard-coded in a rigid sequence. Instead, agents decide their next action based on the ongoing dialogue and their defined roles, using their LLM reasoning capabilities. This creates a dynamic, self-correcting loop, allowing for iterative development and debugging. A critical aspect of multi-agent collaboration, especially in coding, is the ability to execute code. Our user proxy agent will be configured to execute Python code. This means that when the software engineer agent proposes a code solution, the user proxy agent can automatically run it in a sandboxed environment and report the output. This feedback loop is indispensable for debugging and verification. Without it, agents would merely generate text without knowing if their code actually works. We'll enable code execution by setting the code execution config parameter in our user proxy agent. This setup simulates a human developer running code in their local environment, but entirely autonomously. It's this active feedback that transforms theoretical code generation into practical, verifiable software development. Let's walk through an example. We'll instruct our coding squad to write a Python function that calculates the nth Fibonacci number. The user proxy agent will give this task to the product manager. The product manager will then break it down and assign the coding task to the software engineer. The software engineer will draft the Python code. Once the code is generated, the QA agent will receive it, potentially from the software engineer, and write test cases to verify its correctness. If the QA agent finds any issues, it will report them back, and the software engineer will iterate on the code. This cycle continues until the QA agent gives its approval, or the user proxy agent intervenes. We'll observe the entire conversation log, seeing how each agent contributes to refining the solution, learning from errors, and ultimately arriving at a correct implementation. This iterative process highlights the robustness of a well-designed multi-agent system. And there you have it. We've successfully built a multi-agent coding squad using Python and AutoGen, capable of taking a high-level request, generating code, testing it, and even self-correcting. We orchestrated different AI roles: a product manager, a software engineer, and a QA tester, all collaborating to solve a programming problem. This architecture isn't just a toy, it's a powerful paradigm for automating complex workflows, debugging code, and even prototyping entire applications. By understanding how to define agents, configure their interactions, and enable code execution, you're now equipped to design your own intelligent systems for a myriad of applications beyond just coding. The future of software development involves leveraging these collaborative AI teams to augment human capabilities. I encourage you to experiment, expand on this framework, and explore how these powerful AutoGen agents can transform your own projects. Start building your own AI dream team today.